So we're going to talk about velocity. Maybe I'll just do this with a marker and get that off there. So when we talk about velocity, we look at our speedometer. The speedometer says miles per hour on it. If you're in a 35 zone, that means that the velocity of your car should be 35 miles traveled per 1 hour of time. Does that make sense? So if we talked about 35, when you said, oh, I'm in a 35, that means a 35 mile per hour zone. All right? That's literally showing us miles per hour. So your speed is given in miles per hour. That is the velocity formula. The velocity formula that you see in your book, in your notebook, you're going to write V for velocity is equal to D, distance, over time. This expression is just like saying miles per hour. Miles per hour. In the metric system, though, we don't use miles, do we? If you're driving your car in another country, 99% of the time, the signs will not be in miles per hour because they're going to be using the metric system. What are they going to be in, Thomas?
The K.
K, that's right. If you have a 50 kph zone, that is not 50 miles per hour. This is much, much slower because this distance, this velocity, is given in kilometers per hour. That is the distance everyone else uses instead of a mile. A kilometer is shorter than a mile. Does that make sense? A kilometer is like around 0.7 miles or 0.67 miles, something like that. It's shorter than a mile. It's just 1,000 meters. You take 1,000 meters. We had this meter stick right here, and we laid it on the ground, and then we folded it over, and then we folded it over, and we just kept going down the street, and we did that 1,000 times. We will have marked off 1 kilometer, 1,000 meters, right? Everybody with me? So, kilometers per hour, that's what most people use in the world when they're driving their car, all right? Well, when today, we're going to measure the speed of a little RC car. Do you think that we should measure the speed of a little toy car? Should we measure that speed in kilometers per hour? Should we take this car outside and drive it for a kilometer and see how long it goes? Long it takes to go that far. So no, we absolutely should not. It's just like if we had an ant, we would not measure the speed of an ant in miles per hour. How fast does that ant go? No one would talk about the speed of an ant in miles per hour, right? So another thing that I want you to put in your notes, right? Make a little star. We like to use appropriate units. Just put that. You've got V is equal to D over T. Make a little star right. We need to use appropriate units. Miles per hour isn't an appropriate unit for a little tiny car that's like this big. Doesn't make any sense, right? All right. We know that this is a meter stick. So we could time how long it takes this car to drive down a little track. And we could build that track with our meter stick, right? Does that make sense? So an appropriate unit for velocity for a little RC car would be the distance we could do in meters, all right? Sometimes you'll see me write meters like this. And then sometimes you'll see me write meters ER. Doesn't matter. ER is how we spell it in the United States. RE is how they spell it in other countries that use the English language. All right? So don't worry about that. I just do it sometimes one way and I do it sometimes the other way. Okay? It doesn't matter. So an appropriate distance would be meters, and then we're going to use our phones for stopwatches. And what units of time are we going to time these cars in?
Meters.
Now, the meters is the distance. So we're using our stopwatches, which is going to show what units of time.
Seconds.
Seconds, that's exactly right. Seconds. I would rather you have said meters, because you kind of misunderstood what I said, than just stared at me blankly when you knew exactly what the answer was. All right. So when we measure the velocity of our car, when we get the velocity of our car, it's going to be in meters per second. So let's say we had a car that went really fast. Our cars probably went, well, one of the fastest might be, let's say we had a car that could go 4 meters every second. That'd be pretty quick. That'd be 4m/s, 4 meters per second. Does that make sense? All right. How are we going to do this? We're going to go outside. We're going to create a track, and we're going to find the velocity of 3 different remote control cars. All right. We've got 3 different remote control cars. Maybe 4. No, I think I've got 4 now because there's 4. So we're going to break up into groups. Here's how that's going to go. We're still taking notes. I want you to draw this picture in your notes. All right? All right? You are going to do this picture 4 times when we do the lab, but I want you to draw it once in your notes. It's very simple. All right, we'll say the first car, I'm going to draw a little pickup. We've got a little F-150 pickup right there. All right? So draw a little pickup on the left side of your notebook and then make a line out in front of it. This line is going to represent the track that the car is driving down. So just draw. You don't have to be an artist. It doesn't have to be perfect. Draw a little pickup that's a couple lines high or something, Aubrey, just like you're doing. That's exactly what I want you to do. And then draw a line in front of it. If we want to get accurate information about something that's traveling as fast as a remote control car, we probably would want the track to be longer than 1 meter. And we looked at that yesterday, because if the car is going like this, then you would have to start timing here and stop timing there. And any little mistake would throw it off, right? So we'll go out and make some tracks. We're going to have 4 different tracks because we have 4 different cars. And the tracks are going to be at different lengths. Each track should be at least 4 meters long, all right? So let's pretend we have a 4 meter long track. So you would have 1, 2, 3, 4. This is your start line right here. Start. And this is where you would start timing. And then the car would go 1, 2, 3, 4. 4 is the finish line. So jot that down. Jot that down real quick. I remember we went outside yesterday. And we did this one time, right? And then you found out that sometimes it's kind of hard to use your stopwatch on your phone. Like you got to do a little practice, right? You can miss the button or whatever. So let's pretend we were outside and this is a little RC truck and the batteries are low, so it goes pretty slow, okay? Is everybody with me? And let's say this car was going very slowly and we had a timer, all right? We're using our phone for a timer. When the car passed the start line, we hit go and the stopwatch was running. And then when the front of the car got to the finish line, right, we hit stop. If we timed it from the front here, we have to time it from the front here. Everybody agree with that? And let's say it took 12 seconds. That is the time. Everybody agree with that? So if we do the velocity formula and solve for how fast this car goes, in this situation, this car would have gone 4 meters and it would have taken 12 seconds. So the velocity of this car is 4 meters per 12 seconds. Now that's not a good enough number. So we would take our calculator and we would hit 4 divided by 12. And I just happen to know that off the top of my head. I tried to make sure I made up some easy numbers we could do that with. 4 divided by 12, right, is 0.33 meters per second. So this car really only goes 1/3 of a meter every second. That would be its velocity. Does that make sense? So I want you to copy this down, right? Understand that we're going to draw the car and we're going to draw the track. And this is how we calculate velocity. For big cars, we use kilometers per hour. For a little car, we might use meters per second. All right. So we went outside. We created 4 different tracks. The track for the truck was 4 meters. For the crazy car was 8 meters. For the Camaro, which was kind of not working well, was supposed to be 3 meters. And then for this other crazy car with the orange wheels, that track was 6 meters. And then you timed how long it took them to go. So now we can get the velocity of each car. What I'm going to do now, I filmed one of them. I filmed a group doing the crazy car and the crazy car going for 8 meters. So I'm going to do the math with them, okay, for the crazy car. And let's take a look at it. The crazy car, and we've got it on video. A little warm out there. We got the crazy car on video. It went 8 meters. So we're going to do the velocity formula. I want you right now to do the velocity formula for your crazy car. All right? I'm going to call out the numbers for Maddie's group. The velocity of the crazy car was equal to distance. It went 8 meters. And then we used our stopwatch to time how long it took to go those 8 meters. Maddie, how long did the crazy car take to go 8 meters? 2.6 seconds. So it went 8 meters in 2.6 seconds. And if anybody watches that on video, they will be able to time it themselves. It went 8 meters in 2.6 seconds. So we're going to calculate. Hey, did anybody else have 2.6 for the crazy car? What'd y'all have, Mason?
I don't think we did the crazy car.
Everybody was supposed to do all 4. Emmer, you were in that group. Emmer?
2.5.
Y'all got 2.5? Wow, that's good. We're only off a tenth of a second. Lillian?
We didn't get
Aubrey? Micah?
2.66.
So y'all got 2.7 or 2.66. That's good. So these are all going to be really close. So I use my calculator. Y'all use your own numbers. I'm going to say the velocity of the crazy car we'll say 8 divided by 2.6 equals 3.07. I'll just round that off to 3.1. It was actually 3.07. We don't need to use that many decimals. So you know, the 7 would make this number go up to a 1, correct? So it's 3.1. What are the units? 3.1 meters per second. That was the speed. And anybody else that did the crazy car, I bet yours is pretty close. Does that make sense? All right. You can go in the room now. You can split up and get with your groups at a different table. There's a whole bunch of calculators right here. And I want you to calculate the 4 cars that you did. All right? Go.